Hello everyone, this is Srikar. In this video, we're gonna see a single linked list with Java. Single linked list is a linear data structure where where a sequence of nodes are connected to each other in a linear manner. And as it is a single linked list, it contains two parts. One is data part, another is pointer part, which points to the next node as in this way. Here also a data part and a pointer part. This points to the next node. In this way, a linked list is designed. So, what is the usage of this? Overrides the disadvantage of array like, and here we can the size of linked list is depends upon the requirements, and we can insert anywhere in any node in between the linked list. So now let's see the algorithm for this. To make it fast, I have written the algorithm first itself. The algorithm is first create a class node which has two attributes, data and next. As we have discussed, this next is this pointer thing. First, we have to create a node class. In that class, we have to create two variables, data and next. So here itself, we shall start the code class node. Yeah, int we are storing int type data. We have to point this, so we are creating a node pointer node next. In this next stores the node address of the another next node. uh, and now we have to initialization. We use using the constructor. We're going to initialize this node of data int data. This is the data which we get from the other from the user or anything. Now we have to assign this data to the existing data. So this works as this dot data equals to data. Now we have to make this null. Next pointer to null. Else there would be a garbage value and it may lead to another. It may lead to some uh, loops. Next equals to null. That's it. We have created a node class with data and next. Now create a class which has two attributes, head and tail. Mm. In linked list, we have two parts basically. The first part is called as head, and, and the last part is called as tail, which makes it simpler to access the first and last parts of the nodes easily. Now let's write another class SLR. In this class, what we have to create is in a head and tail node head head equals to null because at the initial thing the head and tail has no nodes. Only after creating we will assign head and tail the nodes. So initially it should be nulls. Tail equals to null. No. After that add node. So we are having head and tail. Let me clear this. Usually we have head and tail, both are null. Now what we have to do is we are adding a node. So but the basic thing is we have to create a node, and after creating we have to check whether the head equals to null. If head equals to null, then it is the first node we have created. So we have to assign head and tail both to the new node. If head not equals to none, if head may have another value, then we have to go to the last node, which is tail, and assign to the new node. Let me do the coding part so it will be easy to understand. As we are not returning anything for add node, algorithm is create a new node. First we have to create a new node. So we shall name it as new node equals to new operator node. We are passing data. Here we gonna pass data from here to the new node. Now we have to check is if the if first checks it first checks whether the head is equal to null, which means the list is empty. If head equals to null, the list is empty and we can add to the head. If head equals to null, if head equals to null, head equals to new node, and tail is also new node because it's having only one node. That will be the new node. And later, if the list is empty, both head and tail will point to the newly added node. What if there is a already existing nodes? If already existing nodes, then what we have to do? We have to go to the tail part. If we are having one over here, in this case, this pointing to this one and this pointing to this one. Now we have taken a node 4. Now what we have to do is this is the tail part and this is the head part, right? Now we have to take this tails next and point to the this, and after pointing we have to make this as a tail. That's simple. Only two steps. We have to go to the tail, point to the tails next to the new node, and the next step we have to make the new node as the tail. Just two steps. Else nails block what was tail dot next equals to new node. Now we have to make the new node to the tail. Tail equals to new node. This tail dot next will make the pointer to the new node, and then it will be completed. Now we have to write the display function. Display function will display the nodes present in the list. Define a node currently which initially points to the head of the list. First, we have to make a demo node, make a temporary node, and point to the head. Traverse to the list till the current points to null. Display each node by making the current to point to the node next in each iteration. This is simply there. Here we have to make a temp node. This head we have to point a temp node to the head, and later by using temp.next we have to traverse through all the nodes, and after reaching the last node we have to try to point to the new node where there will be no node which will return null. The traversal will be end, so we can print in this way. Let's write the code. It will be easy. Very simple thing. The linked list is very easy to understand, but we have to have a good practice. Next, now first we have to take node temp and assign it to the head. We have to traverse. So as no, we use the while loop, it will be easy. Temp not equals to none. Keep on traversing by printing the nodes. Sorry, Forgot to put semicolon. No. Now first we would print the node value. 10 dot data. Let's have a arrow pointing this. It's a concatenation operator. Let's after we have printed the first value. Next we have to traverse the next. That symbol is temp equals to temp dot next. That's it. In two steps we have finished it. Now let's write the main method. VSVM is a shortcut in VS Code we can use. Now first create an object for SLL single single linked list goes to new SLL. We have created an object. Now we shall add some nodes from here. SLL dot add node. Let's set one. SLL dot add node 3. Now let's print this SLL dot display. I think that's it. Now let's run the code. Here you can see the output in the new lines because we have put here ln new line. Now let's run it. Here you can see 1, 2, 3 in the order. Um, Let me explain how this works. First, an SLL object is created, SLL.addNode, which means it goes to the addNode method, and we have passed one over here. So a new node is created. Here is everything here. This is the new node. Let's assume new node with data as well, and this is the null. Well, we have created as null. It's because here we in this creator constructor from here we have created that, and if head equals to null, as usual head is null, head and tails are both null in the first stage. So now what we will do, head equals to new node and tail equals to new node. Here head and tail both points to the new node. Now after that we again come back to here and add new node 2. Now what it happens is a new node is created, a new node with data 2 is created in this step. Now if head equals to null, head equals to null, no. It has a new node, it has a node, so it comes to the else. Now tail dot next equals to new node means this null will be erased and this will be point to the new node, which is the second node we have created, and tail will be the new node. Tail now points to the new node that we have created. Now again this comes to here and we are adding a third node as data value 3. Now again new node is created with the data 3, and if it equals to null, no, it has a node and else tail dot next equals to new node. Tails next is actually null. Now it's gonna point to the new node that we have created just now, and tail equals to new node. Tail equals to new node. This now tail gonna point to this third node we have created just now. Now in the next step we're gonna come to SLL.display. Here display function will be created. A new node, a temp gonna point to the head node. It's a temporary variable. Now temp not equals to null until temp not equals to null, which means it has a data. So first we're gonna print temp dot data. Output is output. First arrow dot temp dot data. First we get an arrow and we are having a temp dot data, right? The temp dot data is 1. So 1 will be printed, and next temp equals to temp dot next, which means this temp dot next, this address will be pointed to the temp, which means is gonna be the temp now. So again the loop repeats. Temp not equals to null. Is temp is null? No. Temp has a value. So now again print temp dot data. Now again an arrow. Temp dot data. Temp dot data is 2. Now again next. This will be pointed. This next node will be pointed to the temp. Here we again print an arrow with temp dot data. What is the temp dot data? 3. So 3 will be printed. Now temp equals to temp next. Now we are pointing to the next node, but actually it is a null here, right? So temp not equals to null, but here we can say temp equals to temp. There is nothing another node, so it is a null. So now we get out of the loop and we exit from the code. Okay, guys, this is the video. Thank you.